Okay, Assalamualaikum warahmatullahi wabarakatuh. Welcome back. We are going to look at the what we call the apps. Our lab session today will be santai-santai lah, insyaAllah. Because this week I think I want you to familiarize with yourself with these apps, with these apps, so you can try to explore on your own, and then you try to complete the work with your group, with the group that you form 3 to 4 students, 3 to 4 students in one group, same group with group assignment that you, the first assignment that I have given to you. Okay. So this slide that is prepared by the coordinator of this subject, which is prepared by Dr. Hanif Ramli. This short handout, 20 pages, 20 slides. We talk about IoT interface, apps simulation. Since most of you cannot come to study in campus, so that's why we have to make adjustment for your lab. You cannot access Simulink and MATLAB that we have in our computer lab in our faculty. So that's why we introduce your lab session to be to use Arduino open source. Okay, this is basically IoT interface apps and simulation. Okay. Okay, so what I'm planning to cover for lab briefing for today is a bit on the introduction of Tinkercad. Okay, Tinkercad, and then how to set up. This is Tinkercad, and then how to set up Tinkercad environment. Okay, environment, and then you can try the first simulation program. Okay. So this one will be the first part of your lab. I hope you can try on your own. This is part 1, and then we go to part 2, which is introduction of a circuit generator freezing, and then how to do the setting for your freezing environment. Okay. Okay, as you all know, maybe how many of you already knew about Autodesk Tinkercad? Any one of you? Just want to check. Or this is the first time you hear about this? Anybody? Anybody has been exposed
Trial
to this?
version.
Hello? Any one of you?
First time, sir.
First time, huh? Okay, good. So I hope you can explore, try to explore. Because before this we use MATLAB, MATLAB and Simulink. Okay, that one also can be installed. But for the purpose of this class, to standardize throughout the class, so we use this as a design tool for your lab. Okay, this is an open source. You don't have to pay anything. Okay, we call Autodesk Tinkercad. Okay, Autodesk is a very famous company. Their main business is in CAD, computer-aided design. Okay, to do solid modeling, and and then they develop Autodesk Tinkercad. Okay, you can see here, the figure. Okay, these are the things that you're going to explore. It's very interesting. I hope that you will enjoy exploring this, because this is very useful for you as your selling point when you work later on. Okay, so Autodesk Tinkercad, what is it about? Okay, it is a free online collection of software tools, okay, that help people all over the world help people all over the world. They can use their brain, to think, okay, to create and then make the design possible. Okay, so this is free online collection. This is the first one. Okay, second one, Tinkercad comes with three dimensional CAD, computer aided design. Okay, and then we have a circuit design, and then we have also for Tinkercad they have programming environment. Okay, uh, programming environment using Arduino and code blocks. So, meaning you can once you have assembled it, you can extract their programming coding, their coding, computer coding. To write it's not easy, but from there you can extract, and then from there you can manipulate or can modify the coding, okay, based on your need. Okay, so one of the good thing about the Tinkerboard is you can use and browse it using web browsing without downloading any software. So this is a good point, good plus point about it. And Tinkerboard is extremely intuitive and easy to use. Okay, and they also have a help lesson. Okay, you can use the click help button, so for that you can learn. Okay, starting from beginner and then intermediate and advanced. So as a beginner, young people or old people or senior people, they can. It's very user friendly to be used. Okay. So last but not least is Tinkerboard is a superior version of phrasing. Okay. That's what they say lah. Is one of the superior version of phrasing. Okay. All right. Next one is how the Tinkercad looks like. Okay, you can try or open on your own. Okay, Tinkerboard circuit design. Okay, they have different button over here. Okay, code and then simulation export, and then this is Arduino Twin OR3, and then you have here block. Okay, button for input, output, control, mathematic, variable, and then you can set built-in LED and then servo. Okay, so all of this you can do the selection. Okay, and then this is the board that is shown here. This is Arduino. Okay, how they do this the setup of this one. Okay, this is just a general overview about this. And then next one is about circuit design, okay, and simulation. Okay, so what I would like to highlight here is highlight a few things over here. About number one is it embed the circuit design. It embed all necessary component. Okay, so we will have components such as LED. Okay, LED. So in this class, we learn about resistor, okay, and then servo motor, analog sensor, and etc. Okay, so these are the component that's already there in the selection button. Okay, and then another thing that I would like to highlight is offer also intermediate hardware design, okay, and simulation before you can prototype it, okay, to do the prototyping of it, okay, before you can produce it, okay, you can simulate, you test whether it's okay, not okay, is it optimum or not, whether does it work or not, okay, and then another thing in terms of cost, okay, cost. This one we have different component, okay, and then this one what I try to say here is you can simulate it. before the real production. Then here, simulation results. After you have done this, you can compare with other people's work, with others. Okay, try to compare okay or not okay by other professional. Okay, your result. Okay, this one, what I'm trying to say is double cost. Once you have do the simulation, okay, you didn't do any testing. Because sometimes if you didn't do the simulation, and then you straight away do, to produce it, then the cost of production is not cheap. It's not cheap. Same thing what happened to me last time. We have done an analysis, and then when we start to do production, I design, as I mentioned, I design a spare part for human body. This is for knee, knee spare part, knee implant. So when they start to do testing, okay, testing, this is jig. They start to do testing, standard testing, okay, and then we without having at certain loading, it start to crack. Yeah. We have try how many sample? 3 sample. Sample 1 okay, sample 2 not okay. Sample 3 not okay. Now we could produce another 7. I said, oh, cannot be like that because every sample is very expensive. It costs about 10,000 and 10,000 ringgit. If we try not to do the proper simulation and proper design, we're going to waste a lot of money. Okay, and 1 sample out of 9. And so once it fails, you need to analyze. That's why we'll go back to this this thing that when we say about cost effective, based on a simulation, we can save a lot of money. We can try to identify what the problem will be, okay, before we start to do the real testing and in the real environment. Okay, so only acquire optimal component when you want to do testing. Okay, that is very important. That's the beauty of simulation. That is related with IR 4.0. We do the simulation before the actual one. Okay. Okay, this is a tutorial. I think this one you can try on your own. Take your own sweet time. You can do on your own and make sure you discuss with your group member. Okay, tutorial of Tinkerboard. You can go how to use Circleboard design Tinkercad. You go to this HTTP, okay, www.tinkercad.com. Then you log in to the website, and then you can create your own dashboard. Okay, dashboard, create new circuit. Okay, and then we have here different option here. Circuit, you create circuit, create new circuit. Okay, create new circuit. Okay, and then you create project. Okay, now you will have your own design canvas. Name your design. Is auto generated. Please consider change it, and then these are the button or the icon that you can select. This is what we call design canvas, where you can put all of your components. Okay, you can try to explore. You to navigate. Okay, basic components, starter, Arduino, and then you select Arduino. Okay, and then you choose the template link, and this is the simplest design for you to design or to begin with. Okay, and then as I mentioned just now, you can start the simulation, study the program, which on code tab, and then to study the program, what you can do is you click on code tab. Okay, code tab. To run the simulation, simply you click start simulation, and then it will start the simulation. And this, what will happen? Basically, this will make the LED blinking. You can see it slow and fast by changing the value of the delay bracket. Okay, these are the program. Okay, that the one in the dotted line here. Okay, this is uh, the programming. Okay, coding, computer coding of it. Okay, okay, this is the coding of it. Okay, this is exercise one. Exercise one. What you need to do? Try and assemble the component, and then study the program, and then modify the program. I want you to observe and record your finding. Okay. Tengoklah cepat ke, pelan ke. Uh, what is your observation? And then you report your finding. Okay. All right. I think that's all. I leave it to you. Any question? Do you have any question? If you do it fast, you can do it very quickly. So use this time to explore. I know it's with a new norm, it's not easy, but you can have your own chat room or can discuss with your group. Okay, what to do. Okay, so you submit next week. Okay, any question? Ramzi, if you have any question, hopefully you will enjoy using Tinkercad. Yeah, Tinkercad. Shariman, any question? Many friends in your house? Muhammad Lokman, are you here or not? Okay, what I want you to do now, start to form the group and then start to prepare the assignment given and also the tutorial for Tinkercad. Okay.